Thanks for watching, and let's practice with the method of characteristics. And in particular, let's solve the PDE ut plus ux plus u is e to the x plus 2t with initial condition 0. So, just as usual, let x of t be the characteristic curve. So let x, which is x of t, be the characteristic curve. And what we want to consider is the value of your solution on your curve. So let h, which is h of t, which is really u of x of t, comma t, be the value of u on that curve. And in particular, what we want to do, we want to now calculate the derivative of h with respect to t and see if we get something interesting. And now remember, for our next step, we want to calculate the derivative of h with respect to t. So h prime of t, remember this is d over dt of the value of u on the curve, u of xt comma t. So now we want to use the chain rule because u depends on x and t, x depends on t, and t depends on t. So what this is saying is this derivative is du over dx times dx over dt plus du over dt times dt over dt. So now let's use the chain rule. So this is partial u over partial x, and then dx over dt plus partial u over partial t, and then dt over dt. Which, in other words, becomes ux times x prime of t plus ut times 1. And here is precisely where we want to use the PDE. Because remember, our PDE, if I'm not mistaken, was ut plus, I believe, ux plus u is e to the x plus 2t. And in particular, we can solve for ut here. So this becomes ux times x prime of t, and now plus e to the x plus 2t, and then minus ux, and then minus u. And the nice thing is, this ux here factors out, and we're left with ux times x prime of t minus 1 plus e to the x plus 2t minus u, which once again is h prime of t. Now, unfortunately, h is not constant here anymore, but we can still simplify this equation a bit by setting the terms in parentheses equals to 0, which at least will give us now the characteristic curve. So, step 2. So, characteristic ODE. Actually, there are two of them, which is quite interesting. So, on the one hand, we can set the stuff in parentheses equal to 0. So, x prime of t minus 1 is 0. So, x prime of t is 1, which tells us that x of t is t plus c. So, that's already interesting. It tells us that the characteristic curves in this case are just straight lines, because that would be x of t comma t. That's on the one hand. On the other hand, now our ODE for h simplifies, because now what we get is h prime of t, that was, I believe, ux And now, times x prime minus 1, so 0. And then, plus e to the x plus 2t, and then minus u. But I want to remind you this u is evaluated on the curve. And in particular, by our definition, this is the same thing as h. And so we end up getting h prime of t is minus h of t plus e of x plus 2t. That's already very good, but we can simplify this now even further because remember, we have a formula of x. So x is t plus c, so this now becomes minus h of t plus e of t plus c plus 2t. And in particular now, we get a much simpler ODE for h. So we get what's called a second characteristic ODE, which in this case is h prime of t is minus h of t, and then plus e, I believe, to the 3t plus c, if I'm not mistaken. Let me check. Yes. And now, this is another characteristic ODE which we can solve for now. So I believe step 3, solve for h. And notice, this is really of the form, if you want y prime of t equals minus y of t plus e to the 3t plus c, which you can solve using integrating factors. So let's do that. We can rewrite the ODE in standard form. H prime of t plus h of t is e of 3t plus c. Claro que sí. And in particular, the integrating factor is e to the integral of 1, which is e to the t. So integrating factor is e to the t. So what we can do, we can just multiply both sides by e to the t. So et wants to go home, but also et wants to solve the differential equation. So et times this is et times e to the 3t plus c. And once again, by the magic of integrating factors, this becomes a derivative, because that's a derivative of et and an h of t prime. And you can simplify this if you wish. This becomes e to the c times e to the 4t. And then all you really have to do now is integrate. So that was the ODE we got so far, and now integrating, we get the following. So e to the th of t is integral e to the c e to the 4t dt, and that becomes e to the c, and then 1/4 e to the 4t, and then plus another constant. We already use c, so let's use b for example. And then we can just solve for h. So h of t is e to the minus t, and then 1/4, if you want, e to the 4t plus c plus b. And in the end, we now get h of t is, if I'm not mistaken, 1/4 e to the 3t plus c, and then plus b e to the minus. That's very good. Now, what we know is the value of u on that curve, and what we'll do now is we solve for b, and then eventually we'll be able to solve for u of xt. So let's do that now. So once again, that was the function h we found so far, but now remember, h is the value of u on the curve. So 1/4 e to the 3t plus c plus b e to the minus t. But now, if you notice, there's one thing we have not used yet, which is the initial condition. So let's do that now. So at t equals 0, we have u of x0, comma 0 is 1/4 e to the 0 plus c plus b e to the 0. But remember, u of x0 was just 0. So now we get 0 is 1/4 e to the c plus b. And in particular now, we can solve for b in terms of c. So b is minus 1/4 e to the c. Now, if this weren't 0, you would calculate, by the way, x of 0, which in this case would be 0 plus c, and you will get a slightly different equation. Okay, and now what we end up getting, we have now h of t is 1/4 e to the 3t plus c, and then minus 1/4 e to the c, and then e to the minus t. And then we're almost done, because remember, h is sort of u, but we need to tweak things a bit. So now, this is h. I just rewrote it just slightly. And now remember, what is h? It's the value of u on the curve. So u of xt comma t is 1/4 e to the 3t plus c minus 1/4 e to the c minus t. And lastly, remember that x is just t plus c. So u of t plus c comma t is 1/4 e to the 3t plus c minus 1/4 e to the c minus t. And the final step is simply letting this be x, because we want u of xt, and solving for c, or at least, solving for c in terms of x and t. So step 6, let x be t plus c. So in this case, c is x minus t. And then what we end up getting is u of x comma t is u of t plus c comma t. And that becomes 1/4 e of 3t plus c. In other words, 3t plus x minus t. And then minus 1/4 e of x minus t minus t. And this we can simplify just a little bit further. So here I just rewrote it, and you get 1/4 e, I believe, of 2t plus x minus 1/4 e of x minus 2t. And now the cool thing is, by the way, so there is a common factor of x, or e to the x. So you can factor this out, and you get 1/4 e to the 2t minus 1/4 e to the minus 2t. Now, this smells a little bit like sinh, which we've learned about in the Laplace section. So let's just factor out a 1/2. So e to the x, 1/2, and then e to the 2t minus e to the minus 2t over 2. And the cool thing is, now this becomes sinh of 2t. So we get 1/2 e to the x, sinh of 2t. And this, lo and behold, is our solution, u of xt. Now, if you want, if you have time, you can check that u in particular satisfies the PDE. That's a great way of checking your work. But here, let's just check if the initial condition is true. So, small check. Let's do u of x0. That becomes 1/2 e to the x, sinh of 0. However, sinh of 0 is 0, and so in the end, we do get that at least the initial condition is satisfied. All right, I hope you like this. If you want to see more math, please make sure to subscribe to my channel. Thank you very much.